Our sun is a powerful star. It gives us light and warmth, but the sun can also unleash bursts of energy. We call these solar storms. These storms are powerful events. They can affect Earth and our technology. Solar storms happen when the sun's magnetic field changes. These changes can release huge amounts of energy. This energy travels through space as radiation and charged particles. These storms are a reminder of the sun's power. They show us that we live in a dynamic solar system. Understanding solar storms is important. It helps us prepare for their potential impacts on Earth. Imagine a sneeze so powerful it sends a cloud of material racing through space. That's a coronal mass ejection, or CME. CMEs are giant bursts of solar wind plasma. They erupt from the sun's corona, its outermost layer. These eruptions are driven by the sun's magnetic field. They can travel at incredible speeds. When a CME reaches Earth, it can interact with our planet's magnetic field. This interaction can trigger a geomagnetic storm. CMEs are a key part of what we call space weather. They can have significant effects on Earth's technology and infrastructure. Understanding CMEs is crucial for predicting and mitigating the impacts of solar storms. Earth has a secret weapon against solar storms: its magnetic field. This field acts like a shield, protecting us from the sun's harmful radiation. Imagine a giant bubble surrounding our planet, deflecting the constant stream of charged particles from the sun. This magnetic field is generated by Earth's core. It's essential for life as we know it. Without it, the sun's radiation would strip away our atmosphere and make Earth uninhabitable. However, even the strongest shield has its limits. During intense solar storms, the sun's energy can penetrate Earth's magnetic field. This can disrupt our technology and create stunning auroras. One of the most beautiful effects of solar storms is the aurora. These natural light displays, known as auroras, are a breathtaking phenomenon that has fascinated humans for centuries. They are often referred to as the northern lights, or aurora borealis, in the northern hemisphere, and the southern lights, or aurora australis, in the southern hemisphere. These shimmering curtains of light dance across the night sky, captivating observers. The lights can appear in various forms, from patches or scattered clouds of light to streamers, arcs, rippling curtains, or shooting rays that light up the sky with an eerie glow. Auroras occur when charged particles from the sun collide with atoms in Earth's atmosphere. These particles are carried towards Earth by the solar wind, a stream of charged particles released from the upper atmosphere of the sun. These collisions excite the atoms, causing them to release light. The process is similar to how neon lights work, where electricity excites the gas inside the tube, causing it to glow. The color of the aurora depends on the type of atom involved. Oxygen, for example, can produce green or red light, while nitrogen can create blue or purple hues. Green auroras are produced by oxygen, which is the most common color seen in auroras. This green light is typically emitted at altitudes of around 100 kilometers above the Earth's surface. While nitrogen can create blue or red hues, blue light is usually seen at lower altitudes, while red light can be observed at higher altitudes. Typically, auroras are visible near Earth's poles. This is because the magnetic field lines of the Earth converge at the poles, guiding the charged particles towards these regions. However, during strong solar storms, they can appear at lower latitudes. These storms can cause the auroras to be visible in places where they are not usually seen, creating a rare and spectacular sight for those lucky enough to witness it. These celestial displays are a reminder of the sun's power and the dynamic nature of our solar system. They serve as a beautiful and awe-inspiring connection between our planet and the star that gives us life, highlighting the intricate and delicate balance of the natural world. Section 5. Tech at Risk. The impact on our technology. Our modern world relies heavily on technology. From the smartphones in our pockets to the satellites orbiting our planet, technology is deeply integrated into our daily lives. We depend on it for communication, navigation, entertainment, and even for critical infrastructure like power grids and water supply systems. But, this technology is vulnerable to solar storms. These solar storms, also known as coronal mass ejections, CMEs, are massive bursts of solar wind and magnetic fields rising above the solar corona or being released into space. When these charged particles reach Earth, they can have profound effects on our technology. When a CME hits Earth, it can disrupt satellites, communication systems, and even power grids. The impact can be widespread, affecting everything from our daily phone calls to the stability of our electrical infrastructure. Imagine a world where your GPS suddenly stops working, or where the power grid fails, plunging cities into darkness. The charged particles from the sun can interfere with radio signals. This interference can lead to a loss of communication, which is critical for emergency services, aviation, and maritime operations. The reliability of our communication networks is something we often take for granted, but solar storms remind us of their vulnerability. This can cause disruptions in GPS navigation, satellite TV broadcasts, and even air traffic control. For instance, pilots rely on GPS for navigation, and any disruption can pose serious risks. Similarly, satellite TV services can experience outages, affecting millions of viewers. In extreme cases, solar storms can damage sensitive electronics in satellites, leading to costly repairs or even complete failure. The financial implications of such damage are significant, not to mention the potential loss of critical data and services that these satellites provide. Protecting our technology from solar storms is a growing concern. Scientists and engineers are working tirelessly to develop better shielding and more resilient systems to withstand these solar events. This involves not only improving the hardware but also developing advanced forecasting methods to predict solar storms and mitigate their impact. Engineers are constantly working on ways to make our systems more resilient to these events. This includes designing more robust satellites, enhancing the durability of power grids, and ensuring that communication networks can recover quickly from disruptions. The goal is to create a technological infrastructure that can withstand the unpredictable nature of space weather, ensuring that our modern way of life remains uninterrupted. Section 6. Power grids in peril. The threat to our electricity. Imagine a world without electricity. No lights, no internet, no refrigeration. Solar storms have the potential to cause widespread blackouts by disrupting power grids. When a CME hits Earth's magnetic field, it can induce electric currents in long conductors, such as power lines. These currents can overload transformers and cause widespread outages. The 1989 Quebec blackout is a stark reminder of this threat. A severe solar storm caused a province-wide blackout, leaving millions without power for hours. As our reliance on electricity grows, so does the potential impact of solar storms on power grids. Section 7. The 2024 storms. Recent solar events. The year 2024 has been a busy one for solar activity. Solar scientists and enthusiasts alike have been closely monitoring the sun's behavior, as it has shown unprecedented levels of activity. This year has seen a series of solar flares and coronal mass ejections, which have had significant impacts on our planet. In May, the strongest solar storm in over 2 decades hit Earth. This event was marked by a massive release of energy from the sun, which traveled across space and interacted with Earth's magnetic field. The storm was so powerful that it caused spectacular auroras, visible much further south than usual, delighting skywatchers around the world. This storm created 2 new temporary radiation belts around our planet. These belts posed a threat to satellites and other space-based technologies, as the increased radiation levels could potentially damage sensitive electronics. Scientists worked tirelessly to monitor the situation and ensure the safety of our space assets. While there were no major disruptions, it served as a wake-up call. The event highlighted the need for better preparedness and more robust infrastructure to withstand such solar events. It also underscored the importance of continued research and investment in space weather forecasting. More recently, in October 2024, another strong geomagnetic storm impacted Earth. This storm, though not as intense as the one in May, still had significant effects. It caused beautiful auroras and raised concerns about the potential for power grid disruptions. This storm caused concerns about potential power grid disruptions, particularly in areas already hit by recent hurricanes. The combination of natural disasters and space weather events put a strain on emergency services and highlighted the interconnectedness of our modern world. These events highlight the importance of space weather monitoring and preparedness. Scientists and engineers are working together to develop better predictive models and more resilient technologies to protect our infrastructure from the effects of solar storms. As we approach the peak of the sun's 11-year cycle, we can expect more frequent and intense solar storms. This period, known as solar maximum, is characterized by increased sunspot activity and a higher likelihood of solar flares and coronal mass ejections. It is crucial that we remain vigilant and continue to advance our understanding of space weather to mitigate its impacts on our daily lives. Section 8. Eyes on the Sun. Space Weather Monitoring. Just like we monitor weather patterns on Earth, scientists keep a close eye on space weather. This involves tracking solar flares, CMEs, and other solar events that could impact our planet. Space weather forecasting centers around the world use a network of ground-based observatories and satellites to monitor the sun. These observations provide crucial information about the size, speed, and trajectory of CMEs, allowing us to predict potential impacts on Earth. By understanding and monitoring space weather, we can take steps to protect our technology, infrastructure, and astronauts in space. Section 9. The Future of Solar Storms. Understanding our star. Solar storms are a reminder that we live in a dynamic and interconnected solar system. As we become more reliant on technology, understanding and predicting these events becomes increasingly crucial. Scientists continue to study the sun and its behavior, developing new models and tools to improve space weather forecasting. By unraveling the mysteries of our star, we can better protect ourselves from its occasional outbursts. The future of space exploration and our technological civilization depends on our ability to live in harmony with the sun's awesome power.